Hi everyone, welcome back to BrainyLab, where we make science easy to understand. In today's video, we're diving into the second part of our Shells, Subshells, and Orbitals series, subtitled AUFBAU Principles and Diagrams, one of the most essential tools for understanding how electrons are arranged in atoms. By the end of this video, you'll know exactly how to fill orbitals in the proper order and how to write electron configurations like a pro. The word Aufbau comes from a German word that means to build up, and that's precisely what the Aufbau principle is all about. Building up atoms one electron at a time, starting from the lowest energy level. According to the Aufbau principle, electrons always fill the lowest energy orbitals first before moving to higher ones. Think of it like filling seats in a theater. People take the seats closest to the front first because they require the least effort. So in atoms, electrons prefer the orbitals with the lowest energy. Now each shell is further divided into subshells. These are like sections or rooms within a floor. The subshells are labeled as S, P, D, and F. Each type of subshell has a unique shape and can hold a specific number of electrons. The S-ear subshell has 1 orbital and holds 2 electrons. The P subshell has 3 orbitals and holds 6 electrons. The D subshell has 5 orbitals and holds 10 electrons. The F subshell has 7 orbitals and holds 14 electrons. P subshell has 3 orbitals and holds 6 electrons. The D subshell has 5 orbitals and holds 10 electrons. And the F subshell has 7 orbitals and holds 14 electrons. So the first shell, N equals 1, only has an S subshell. The second shell has S and P. The third has S, P, and D, and the fourth has S, P, D, and F. This organization helps explain why electrons fill shells in a specific order. It's all about energy levels. Now let's look at the order in which orbitals fill. It goes as displayed on the screen. The pattern follows increasing energy, but notice something strange. For example, the 4s orbital fills before the 3d orbital. That's because 4s has slightly lower energy when it's empty. This is one of those quirks of quantum mechanics. Let's apply this to real examples. Let's start simple with hydrogen. Hydrogen has 1 electron. To draw our Aufbau diagram, we assign 1 electron to the 1s subshell, which is only half filled since it can hold 2 electrons, as shown on the screen. Let's move on to our following example, helium. Helium has an atomic number of 2, therefore it has 2 electrons. To draw helium's Aufbau diagram, we assign both electrons to the 1s subshell. Please note that the electrons in an orbital must point in opposite directions, representing paired spins. For our third example, we will draw the Aufbau diagram for lithium. Lithium has a proton number of 3. To draw the Aufbau diagram, we assign 2 electrons to fill the 1s orbital and then the remaining one to half fill the 2s orbital. Now let's move on to more complex examples, starting with nitrogen. Nitrogen has an atomic number of 7. To draw the Aufbau diagram, we assign a pair of electrons to both 1s and 2s orbitals. We then step into the p subshells. Remember, the p subshells have 3 orbitals that can hold 2 each. We then assign 1 electron to each orbital, with all arrows pointing in the same direction. This is important to note. When filling orbitals on the same energy level, we first fill all the orbitals with a single electron, all facing in the same direction, before systematically filling them with electrons spinning in the opposite direction. For our final example, we take oxygen. It has an atomic number of 8, therefore 8 electrons. Using the Aufbau order, let's fill the subshells with electrons. First, we assign 2 electrons to the 1s subshell. Remember, the s subshells can only hold 2 electrons. This leaves us with 6 electrons. We then assign 2 more electrons to the 2s subshell, and lastly, assign the remaining 4 to the p subshell. Remember, when filling the p subshells, we first assign 1 electron to each orbital with the arrows pointing in one direction. After that, we start from the first orbital, filling 1 electron in each orbital, but now in the opposite direction. So oxygen's electron configuration is 1s squared, 2s squared, 2p4. Now let's see if you have understood. Pause the video and attempt to draw the Aufbau diagram and the electronic configuration of the following. 1. Fluorine. 2. Neon. You will find the answers at the end of the video. And that's the AUFBAU diagram explained. If you found this helpful, don't forget to like, subscribe, and turn on the bell icon so you don't miss our next video. Salute.